The greatest of human endeavors is a risky business.
Houston, we've had a problem here.
NASA led the world into the exploration of space, but behind the scenes, out of the public eye, mistakes, mishaps, and failures plague the space industry.
Obviously a major malfunction.
Discover how NASA space failures further exploration. April 12, 1981. Earth's pioneer reusable spacecraft, NASA Space Shuttle Columbia, blasts out of the Kennedy Space Center to the cheers of millions worldwide on its first mission into space.
Space Shuttle Columbia with a
22 years later, on January 16, 2003, Columbia blasts off on its 35th mission.
Roger, roll, Columbia.
shuttle in a heads-down, wings-level position for the 8.5-minute ride to orbit.
As the mission enters its 16th and final day in orbit, 80 experiments have been completed in fluid physics, material science, and life science. It has been a successful mission all around, and it's time to return to Earth. Mission Control runs all of its system checks and clearance protocols and examines weather reports to confirm conditions for Columbia's landing.
We are commenting on the cloud cover because all of a sudden this cloud bank had come in and it had gotten very dark and a very low ceiling, so we were commenting, is it going to be okay for them to land? And talking with those folks, they're like, oh, they'll be fine, they'll clear.
And at 8:10 a.m., February 1st, 2003, pilot Willie McCool calmly drops Columbia out of orbit to begin the long glide home. At 8:45 a.m., the external temperature rockets up to 1,600 degrees Celsius, 3,000 degrees Fahrenheit, so routine that the crew shoots a video as they descend. Then suddenly, everything goes wrong. At 8:54 a.m., the crew systems officer in Mission Control announces low readings in the left wing's hydraulic sensors, off the scale low.
Hydraulic return instrumentations.
No, sir, there's not. We've also lost the nose gear down talkback and the right main gear down talkback.
GNC flight.
4 minutes later, the shuttle crosses into Texas from New Mexico at 20 times the speed of sound. 60 seconds later, the low-pressure readings disappear altogether. Capcom reports the signal loss, and Mission Commander Rick Husband clicks his comm button and starts to respond, but never completes Columbia's final radio transmission.
We're also off.
Columbia, Houston, UHF comm check. Columbia, Houston, comm check. Columbia, Houston, UHF comm check.
Pilot's not reporting any RAF at this time. GC flight. GC flight. Fly GC. Lock the doors. Copy. Fido, do you have any tracking?
No, sir.
At that time, I heard someone said that we've had loss of signal. I went back up to the NTD to kind of find out what was going on. And at that time, the astronauts had pretty much had just left in a running pace to go back to their vans to go be with the spouses. Because at that time, we had realized that we had lost the vehicle.
Shortly after 9 a.m., February 1st, 2003, Space Shuttle Columbia breaks apart during re-entry. Columbia and her entire crew are lost.
We had kind of conveyed in the main corridor right out here. And we just said a prayer.
This is real. This wasn't just a bad dream. That was a tough day there. In the past, because of the Challenger incident, we often held our breath when the orbiter was ascending. And of course, when we had SRB separation, everybody took a deep sigh, but we never considered what could happen during re-entry. Or we were hopeful that nothing would happen during re-entry, and now it did.
I have been very good friends with one of the crew members, and I had a discussion with him. And if anything had happened to the orbiter, what should I tell everyone? And so I then, at that time, expressed those words to my coworkers out here. which was, that he holds no animosity for what has happened, and he died doing what he loved.
NASA's response is immediate. Ground all space shuttles, find out what happened, and make sure it never happens again. And do it quickly. The International Space Station and NASA's future depend on it. With the entire program grounded, recovery teams scrambled into the field to gather debris, as satellite data confirms that a hailstorm of evidence has rained down across 2,000 square miles in Texas, Louisiana, and Arkansas. Investigators will have their hands full as Space Shuttle Columbia finally returns to Kennedy Space Center, one piece at a time. Evidence of Columbia's destruction makes its way to Kennedy Space Center. It's delivered to a dedicated hangar where the 84,000 pieces of debris are reassembled, when possible, and laid out on a grid representing the space shuttle.
Initially, because of the high altitude breakup, we weren't that hopeful that we were going to get that much of the orbiter back that would tell us enough information to really help solve the accident.
Less than 40% of Columbia is ultimately recovered, but it's enough for investigators to begin looking for answers. One of the worst tragedies in NASA's history has left the entire space agency with an uncertain future. Grief and confusion combined with a growing concern for the fate of the International Space Station. Just a few miles down the road from the recovery hangar, ISS modules, trusses, and solar arrays are being prepped and ready to fly. It's enough space hardware for 9 shuttle missions. Building the ISS is the #1 priority for the Space Shuttle program. Well, it was before the Columbia disaster. NASA's former chief astronaut and International Space Station commander Peggy Whitson has spent more time in space than any woman on Earth.
The station would not have been built. The shuttle itself is our truck that brings up a lot of the big cargo. Also brings home a lot of the scientific data, the actual samples that need to come home. We had to decrease the crew size on board the International Space Station in order to just maintain the station. Our focus on board the station changed because we couldn't implement the scientific priorities that we had had in mind for that time period. We couldn't continue the assembly. It was very important at that point in time.
Besides the American components, hardware from 3 international space agencies at a cost of billions of dollars sits on the ground, now with no way to get to space. Everything has been designed especially to fit in the space shuttle's payload bay. There is no other rocket system in the world that can carry the components. Back at the hangar, teams of engineers are assembled to learn what happened, how it happened, and how to make sure it never happens again.
We knew we had to do a recovery or a salvage operation of the debris, and we knew we had to set up to do a reconstruction of the debris based on trying to find all that, gather all that information out of the debris and focus it in an investigation.
Although technical expertise is the key to finding the answers NASA seeks, the team is driven by much more than professional pride.
How do you view a family member? I mean, it's basically the same thing. You spend a lot of your life out here working on an orbiter, and it becomes like a family member to you. A lot of people have spent their whole careers out here working on and around her. And so it hurts.
While the NASA family mourns the loss and celebrates the lives of both the astronauts and the spacecraft, it is not something any of them ever want to experience again. So the search for answers is on, and it's personal.
When you first start seeing the pieces come back, as well as it being an emotional task, it ended up turning to be a very daunting task. For that, you're basically now trying to identify a part by reverse engineering.
The Columbia reconstruction effort was all about receiving the debris from the field recovery sites. It was then taking that debris and identifying it as best we could, laying it out in context with each other so that you could see the parts next to each other, identify the fracture surfaces, the dings, the dents, the burn marks, and try to see what the debris was telling you, to be objective about the debris, to let the debris speak to us, not go in there with any preconceived notions or scenarios and as to how the accident occurred or why the accident occurred. Just let the debris speak for itself.
When the re-entry data recorder is found intact in Texas, investigators hope for more answers.
It's shown that the fatal damage originated between leading edge panels 8 and 9.
The debris is telling, at least from a TPS standpoint, that we had some type of breach between RCC panels 8 and 9. Whatever happened, it wasn't like this big gaping hole and we were missing an RCC panel. Or whatever it was very small. You can see a direct hot air flow that came out from in between the RCC panel and our first row of tiles.
It's the only damage. It's unique in its appearance and in its physical properties. There's almost a complete lack of any metallic hardware. Basically, it's all been melted away. That molten residue has been deposited on the backside of the panels.
And you're going to see distinct flow patterns coming up the sidewall of those particular tiles heading in an aft direction. For that to get to that state, it has to see temperatures over 3,100 degrees.
When Columbia hit the atmosphere at over 20 times the speed of sound, and the external temperature soared to 3,000 degrees, that breach in the wing allowed superheated plasma to enter the wing, quickly dooming the spacecraft.
Initial reentry, I think, is Mach 24. It's coming in at about a 40-degree angle, so it's kind of coming in like this, and it's basically plowing its way in. The friction of the orbiter hitting the atmosphere will start creating a surface tension called plasma, and the plasma is pulsating glow. At that time, too, that friction also starts the vehicle heating up. Mach 18 is approximately the speed they'll be going over peak heating, which is about 3 miles per second, and that hole allowed airflow to go into that spar area. And I shouldn't say airflow because that makes it sound very passive. It was hot plasma gas.
With the breach confirmed by the physical examination of the wing and the analysis of information on the data recorder, the question remains, what caused it?
Something has to hit it, something has to pierce it, something has to fail.
Part of the investigation team reviews every frame of video from the launch. A piece of insulating foam is filmed breaking off the external fuel tank a minute and a half into liftoff. The foam loss is not a new thing and has become almost routine, but this piece hits Columbia's left wing as the shuttle speeds away from the launch pad.
Debris cloud was almost a length of the elevon, and that really surprised us because we're thinking that that hit had to be very strong and powerful in order to create that type of debris field.
But how could a piece of insulation destroy a space shuttle? The shocking answers will fundamentally change the space industry. And with growing international pressure from International Space Station partners, NASA would have to create a miracle of engineering, and fast. The intense Columbia investigation confirms a breach in the leading edge of the left wing caused the loss of Columbia and her crew. But what caused the damage? After bombarding a reconstructed wing with various sizes of foam at varying speeds, investigators have their shocking answer at last. A piece of foam traveling 530 miles per hour can puncture the wing. It is proven beyond reasonable doubt that the piece of foam that broke off during launch landed the fatal blow to Columbia.
Fundamental root cause was loss of foam debris from the bipod ramp and striking the orbiter and causing damage. As that particle comes off the tank and really is slowed down, and the orbiter essentially runs into the particle.
The investigation's focus turns to the foam. The full space shuttle is comprised of the orbiter, the space shuttle main engines, the solid rocket boosters, and the external tank, or ET. The 154-foot external tank supplies fuel to the space shuttle main engines during launch and ascent. The ET is actually comprised of 2 fuel tanks. The forward tank, called the LOX tank, contains over 146,000 gallons of liquid oxygen. The rear LH2 tank contains 395,000 gallons of liquid hydrogen. The area between the 2 tanks is called the intertank and contains most of the electronic components necessary during ascent. The foam insulation is a crucial part of every space shuttle's extensive thermal protection system, or TPS. The spray-on foam is designed to protect the tank from the extreme heat of launch and the extreme cold of the liquid fuels.
The foam is basically there to keep ice frost from forming on the outside of the LOX tank and hydrogen tank, because you can't have ice and frost fall off and hit the orbiter on the way up.
When we're tanking the liquid oxygen and liquid hydrogen, you've got to insulate the metallic tank to make sure that the propellants don't boil off. It's also very influential to densify that propellant. In other words, maximize the amount of thrust that you could get out of that volume of propellant.
There are certain areas where it's thicker and on the inner tank where you need it for aerothermal protection on ascent from aerothermal environments.
During launch and descent, extreme aerodynamic heating can create a 1,000-degree difference.
At any one time, you could have within 1 inch of that material about a 600 degree on the outside and about a minus 450 on the inside.
The insulating foam is critical, but why is it coming off? And even more importantly, how can NASA stop it? With the United States Congress demanding answers and billions of dollars of hardware grounded at Kennedy Space Center, NASA is determined to fix the problem and get back to flying. With the International Space Station construction on hold and the shuttle fleet grounded, an extensive investigation places the blame for the destruction of Columbia on foam loss from the external tank. The foam is a critical part of the Space Shuttle's thermal protection system. There are actually 2 layers of TPS on the external tank. The outer layer is designed to dissipate heat through erosion. It burns away during launch and descent, taking excess aerodynamic heat with it. But that's not the problem. The problem is the inner layer, the lightweight closed-cell spray-on foam that is supposed to stay in place. Since external tanks are never reused, it doesn't matter what happens to the foam after the ET is jettisoned. But until then, it's crucial to the protection of both the LOX tank and the LH2 tank, as well as the intertank. NASA had known for years that the foam insulation was a problem. Small pieces of foam were lost on every flight. They even know why it happened and gave it the name popcorning, because most of the foam loss was small bits that popped off during launch. Not at all like the large suitcase-sized chunk that ultimately destroyed Columbia. The external tank's aluminum lithium surface is painted with a primer and then covered with insulating foam. When the foam is sprayed onto the ET, random tiny air pockets form, which can weaken the bond between the painted aluminum alloy skin of the ET and the foam. The issue becomes a problem when the inner tank is purged with nitrogen to decontaminate it and to remove moisture just before launch. In the cryogenic temperatures created by the LOX and hydrogen fuel, the nitrogen liquefies. The liquid nitrogen then can flow through the intertank flange into the empty pockets created during the foam application. Other voids are just filled with air. The air liquefies similar to the nitrogen. When the shuttle heats up during launch and ascent, the liquids turn back to gas and expand, which makes small pieces of the foam pop off.
What we found in there were a lot of defect inclusions that we were surprised to see. We didn't realize some of those inclusions could be rather large.
Large enough to shear a suitcase-sized piece of insulation completely off the external tank and send it careening into Columbia's wing. Ignored and accepted for years, foam loss had simply grown worse, especially in the areas of the ET that weren't smooth, like the left bipod ramp that holds the external tank to the orbiter, the source of the breakaway foam that took down Columbia. NASA learns from their mistakes as the world watches and wonders if the space shuttle will ever fly again. One simple solution is about to make history. NASA determines that pockets of air in the external tank's foam insulation are responsible for the tragic loss of Columbia and her crew. With a $100 billion International Space Station only about 30% complete, research organizations around the world have placed scheduled zero-gravity studies on hold.
We are pre-positioning a lot of hardware and supplies. It is the only orbiting laboratory in the world, and it gives us a capability to do experiments on in a long-duration platform that nothing else has ever provided us before.
Their logistic modules and laboratories are useless until the space shuttle can fly again.
We put together a series of teams that looked at all applications of thermal protection systems on the external tank and highlighted the areas that were of highest concern to us. And we went through a process with the program of evaluating each of those areas and determining which ones we felt like had to be addressed for return to flight.
One of the issues that we saw in the investigation of the accident was that the design that we're putting onto the tank was not what we thought it was. In other words, there were some defects in the material that we could not see through NDE or any kind of inspection technique.
The bipod ramp became a central focus because it was the source of the foam that hit Columbia's wing and the most likely place for the problem to occur again. A simple fix that took some ingenious engineering fixed the problem. The bipod foam was replaced with heaters.
What we determined is that we could replace that whole large foam with heaters mounted at the base of the bipod. That could prevent ice formation. They only are active prior to launch, and then we shut them off before we launch. So in that regard, we were able to get rid of the larger piece of foam.
The foam application process was also a major issue.
What we're trying to do with the foam now and the foam flows that we have now is eliminate or minimize the size and the number of defects that we get when we're spraying the foam.
Now we know that defects on the inside have a big influence on the material performance. Therefore, the way that the material is laid down onto the tank is very important. Previously, those techniques were left fairly open to the liberty of the technician to apply.
Being a manual operation, we wanted to standardize how they did that, just not say go spray foam, give them some sequences and techniques that we would prove through a series of development enhancement and verification activities to show that it would work and it was repeatable is what we were trying to do.
NASA standardized the spray techniques and implemented other safeguards as well. Video recordings of all sprays, a second technician to assure quality, constant monitoring of the foam for consistency, and a more vigorous certification process for technicians. In addition to fixing the external tank issues, NASA also launched a fleet-wide recertification program for all the other Space Shuttle components, the orbiter, solid rocket boosters, and Space Shuttle main engines. The work took 2.5 years. 7 Space Shuttle missions had been postponed, and the International Space Station was years behind schedule. Finally, on July 26, 2005, Discovery and her crew were set to return to space. NASA hung their hope on all they had learned. Would it be enough? The launch is a success. Discovery spent 13 days and 21 hours in space. Along with resupplying the International Space Station, their primary mission was flight safety evaluation and testing, and Discovery and her crew came home. Ultimately, the $100 billion International Space Station was completed and stands as one of the greatest construction projects in human history.
The international cooperation, I think, provides something that we will look back on later and say, hey, that was the first really big peacetime project that so many countries pulled together and completed.
Along with providing a platform for scientific advancement and discovery, the ISS symbolizes global cooperation and demonstrates what is possible when the best of humanity comes together. The Space Shuttle program ended with the final flight of Atlantis in 2011, after 30 years of building, improving, and learning how to operate in the great beyond.
0 and liftoff, the final liftoff of Atlantis on the shoulders of the Space Shuttle. America will continue the dream.
Roger, roll, Atlantis.
Houston now controlling the flight of Atlantis. The Space Shuttle spreads its wings one final time for the start of a sentimental journey into history.
Today, NASA is using all the knowledge it acquired over those 3 decades to venture past Earth's orbit to Mars, where the new Orion spacecraft will land the next generation of the courageous family of space explorers.
It obviously isn't an easy thing to transition to a new program, a new vehicle. I hope that we will be as successful in transitioning, if not more so, but it's important that we try.
Explorers who are driven by the spirit of discovery, and even when faced with the worst tragedies, innovate, fix the problems, and ultimately become better. To go further and discover more.